Hello everyone. Today we're going to start learning about the data structure called a list. So the list is going to show a lot of similarities to the array, which is showing here. I'm highlighting in blue. The shape array, we're going to use this as kind of a guiding principle, and we're just going to perform the same task that we did earlier by filling up this list box. So first, let's initialize array, so the list, excuse me. So the first thing we need to do is write the word list. And you can see we have the open and close greater than or less than signs here. It's preparing us to put in T, the type of element. So this is the data type. And we're going to use strings like we did for the string array. Next is the name, whatever you want to name it. And then here, following the same pattern as up here, we put on the right-hand side the initialization of the string. And you can see autocomplete is helping me out here. And then the last part is the parentheses, because that's the constructor. That's what builds the string. Now we can initialize the string the same way as the shape array, like so, but that's not needed because lists have something special that arrays do not, where we needed to either define the array up front or at least define the number of elements. A list does not require that at all. Here we can just start adding to the list with the add function. Right, so I'm gonna build this, paste it a few times, and populate it the same way that we would our shape array. And now the shape list will have everything that we need. Cool thing about the shape list here is it can also use the for each statement. This works for both the shape list and shape array. You'll see I can just change this ad nauseum, and it works for both instances. Same with all the code inside here. Add, and then we add shape. So we've structured we've structured our loop to work with either the list or the array. That could be useful for a variety of operations. So here we can comment out the shape array just for good measure to show that we are building our list and populating our list box without the need of the array. Now we're using a list. So that's one really easy way to use a list. But let's explore a little bit more with the list. So for now we can ignore the list box because I'm just going to show a little bit about these other functions that exist. Maybe we use the list box in the same way. Yeah, let's use we'll delete the loop, and instead we're going to build a list with integers. And we could still use that list, that loop actually. We'll do a for each, and so let's just maybe display what our list looks like. And we're going to need to convert that to string. So here we would just expect 11, 3 to 5 show up. Nothing particularly interesting. We could have done that with an array. But there's other things we can do with this list data structure with these numbers here. One thing we can do is we can sort this list. So I'm just clicking the add button because that's how we get into this. We're not working with this anymore. So we can take a peek at our debugger here. Trying to see if there's a way to increase the size of the text. I'll just read what we're seeing here. So number list, we already added 11, 3, and 5. The 0th index is 11. The first index is 3. The second index is 5. So it's just adding a new index and it's putting them in the order that I've added them to the list. Now let's see what happens after we run sort here. Now, shown in red, now we have 3, 5, and 11 showing in the list. 3, 5, 11. So that's a cool little function here. We can sort our integers, and that'll be important in a lot of other future data structure courses and analysis and many other details of learning about data structures. Another cool thing we can do with lists is we can find values in our list. So here we'll do something called binary search. We're going to do it twice. And rather than we don't need to loop for now. We're just going to rely on the debugger to kind of see what's happening. So I'm clicking add just to start our function here. Okay, so before we run binary search, take a quick peek at our locals tab here at the bottom. Now we're going to run it, and here we can see what binary search returned. And in this case, it returned -4, which is a bit mysterious, but what it's doing is it's supposed to be pulling the index here, which it is, but it's just doing it in a very strange way. Let's see what it returns after we sort the list. Now this makes a little bit more sense. So here binary search returns 2, and that is the index where 11 is placed. Earlier it was doing some type of negative based index, which is a little bit confusing and hard to follow along, but here we saw binary search do a little bit more of what we would have expected, which is we get the index value returned to us. So we'll just exit the program right here and read a little bit about what it says here. It says searches the list for an element and returns the zero-based index, as we just saw. 11 was, after the sort, 11 was found to be at index 2. So it returns the number 2. So that makes it easy at that point. If I wanted to display it, I could pull it up in such a manner, right? Similar to the way we would index into an array. So that covers everything I'd like to show for lists. Hopefully this was helpful, and we'll talk to you soon. Take care. Bye.